Welcome to UBG Bytes, where we break down the latest in tech and security into bite-sized chunks.
Hey there! Today we're diving into something pretty interesting. A different way to think about how AI agents, automated tools, interact with the web.
Right, it's moving beyond just having them click around like a person.
Yeah, simulating human browsing.
And looking more at using interfaces actually built for machines. We're talking APIs.
Exactly. We're digging into some new research that compares using APIs directly for web automation versus that traditional browser mimicking approach.
And this is super relevant for you, our listeners. If you're in pen testing, red teaming, security research, vulnerability management, understanding how automation works under the hood, especially with APIs versus GUIs, that's core stuff.
Definitely. It changes how you think about attack surfaces, automation capabilities, even just how web services are being interacted with.
Okay, so let's set the stage. Traditional web agents, how have they typically worked?
Well, the classic approach is you build an agent designed to perform tasks online by basically pretending to be a human user.
So clicking buttons, typing in form fields, scrolling pages, interacting with the graphical user interface, the GUI.
Precisely. They need to sort of see the page structure. Often they lean on things like the accessibility tree
Right, the browser's internal map of elements.
to understand what's where, and then they simulate the mouse clicks and keyboard inputs needed to navigate that GUI.
But, and this is the crucial point the research explores, those GUIs, they're built for us, for humans.
Exactly. They're visual, sometimes really complex. Stuff changes dynamically.
Yeah.
And getting anything done can mean a whole sequence of little steps. Click here, type that, wait for this, scroll down.
Which isn't always the most efficient or reliable way for a machine, right?
Yeah.
Especially if the layout changes slightly.
Not at all. It can be brittle. That human-centric design poses real challenges for automation, which leads to the core question in this paper.
What if the agents just skipped the GUI?
What if they use the interfaces designed specifically for machine-to-machine communication?
APIs, application programming interfaces.
Yep. APIs let programs talk directly to the web service's back-end logic. No need to parse HTML or render pixels.
It's usually structured data, right, like JSON or maybe XML, passed over standard web protocols like HTTP, GET requests, POST requests.
Exactly. You're bypassing the whole presentation layer built for human eyes.
So based on that idea, the researchers proposed, two new kinds of agents?
That's right. First, they defined the API-based agent. This one is pure machine talk. It tries to do everything only using API calls.
It just ignores the website's visual front end entirely.
Completely. Think of it like using a command line straight into the service's core functions.
Okay, that's one. What was the other?
The second was the hybrid agent. This one aims for flexibility. It can use both traditional browsing actions and direct API calls.
So it tries to pick the best tool for the job at each step.
Exactly. It can dynamically decide whether to click a button on the page or make a back-end API call, depending on what seems more efficient or effective for that particular part of the task.
Okay, so you've got the traditional browser-only agent, the API-only agent, and this hybrid agent. How did they test them?
They needed a solid benchmark. They used something called Web Arena.
Web Arena. I think I've heard of that. It simulates real websites, right, in sandbox environments.
Yeah, it's designed to be realistic and reproducible. It uses actual web applications, not just mock-ups. And the tasks cover a good range of common online activities.
Like what kind of sites?
Things like managing code on a GitLab instance, planning routes using a mapping service, online shopping both from the customer side and an admin interface.
Okay.
And even interacting with a social forum, kind of like Reddit. So quite diverse.
And success wasn't just about, did it seem to work? It was concrete.
Very concrete. Success was measured by specific outcomes. Did the agent output the correct data it was asked to find? Did the website's state change as expected? Like, is the item actually in the shopping cart? Is the issue created in GitLab? Or did it simply land on a specific target URL if that was the goal? Real, verifiable results.
Got it. Now, the tricky part, I imagine, is getting those APIs for the API-based and hybrid agents. How do they handle that? It's not like every website just hands you perfect API docs.
No, definitely not. And the paper goes into quite a bit of detail here. It involves several methods, really depending on the specific site in the Web Arena benchmark. The easiest case, naturally, was using existing, well-documented APIs. GitLab, for instance, has a huge public REST API. The mapping service used standard geospatial APIs like Nomatim and OpenStreetMap. So sometimes you just read the manual.
But that's probably the exception, right? What if the APIs exist but nobody wrote them down?
Right. For some sites, the researchers had to basically reverse engineer, They inspected the website's own front-end code, looked at the network traffic between the front-end and back-end to find those undocumented private API calls the website itself was using.
So, detective work. Find the API calls the developers used but didn't publish.
Exactly. And sometimes, even if they found the API endpoint, the documentation was missing or just really poor.
So what then?
This is where it gets kind of meta. They actually used large language model GPT-4o specifically to generate the documentation.
Wait, they used AI to write API docs so that another AI could use the API.
Yep. Based on analyzing the code that used the API or observing its behavior, it's like bootstrapping the process.
Wow, okay. That's clever. What if the APIs just weren't there? Like, the site genuinely didn't have an API for a needed function.
That happened too. For the Reddit clone example, they found the existing APIs weren't enough to cover all the tasks, like voting on posts. So they actually had to manually create and add entirely new custom API endpoints to the site's backend code just for the experiment.
So they modified the benchmark site itself to make the API agent viable for certain tasks. That highlights how dependent this approach is on API availability.
Absolutely. It's a crucial factor.
Okay, so let's say they've found or created the APIs and got some documentation generated or otherwise. How does the agent's brain, the LLM, actually use this info? You can't just develop thousands of API endpoints into a prompt, can you?
Good point. The context windows have limits, and cost is a factor. Yeah. They use two main strategies for feeding the API info to the agent.
Okay.
For sites with relatively few APIs, they define this as under 100. Like the map service and the Reddit clone, they use what they call the one-stage approach. Meaning the full documentation for all the available APIs on that site was just stuffed directly into the agent's initial prompt. The LLM saw everything up front.
Okay, feasible for smaller API sets, but for the big ones, like GitLab must have hundreds, thousands maybe.
Exactly. For sites with over 100 APIs, GitLab, the shopping site, the shopping admin interface, that one-stage approach wasn't practical. Too much text, too expensive. So they used a two-stage approach.
How did that work?
In the first stage, the agent's main prompt only contained a list of the APIs available, maybe with just a short one-line description for each, like an index.
Okay, just the names and summaries.
Right. Then when the agent, during its reasoning process, decided it needed to use a specific API, say, the one for getting commits in GitLab, it would call a special tool provided to it.
A tool, like a function call.
Yeah, effectively. They called it getup a documentation. The agent would pass this tool the identifier of the API it wanted, like get a P for project's projected repository commits.
And the tool would?
The tool would then retrieve the detailed documentation, the full readme or the YAML spec for just that specific endpoint and return it to the agent.
Ah, like lazy loading for API docs. Only fetch the details when you actually need them.
Precisely. It keeps the initial prompt manageable, but gives the agent access to the full details on demand.
Clever. And then the agent actually makes the call. How?
It generates Python code, typically using the popular requests library. It writes the code snippet needed to construct the HTTP request with the right parameters, headers, authentication, sends it off, gets the response, usually JSON.
And then parses that JSON response to pull out the information it needs for the task.
Exactly. All happening within a sandboxed execution environment. So the agent isn't just reasoning, it's writing and running code to interact with APIs.
That's quite a sophisticated process. Okay, let's talk results. Did this API-centric approach actually work better on Web Arena?
It definitely made a difference. The findings were pretty clear. Let's start with the pure API-based agent.
The one that only used APIs, ignored the GUI.
Right. There, across all the different tasks in Web Arena, it achieved an average success rate of 29.2%.
Okay, 29.2%. How does that compare to the old way, the browsing agent mimicking clicks?
The browsing agent managed only 14.8% success on average.
Wow, so that's nearly double the success rate just by switching to APIs where possible. A 15-ish% absolute jump.
Yeah, a significant improvement. But the real star was the hybrid agent.
The one that could use both browsing and APIs.
That's the one. It achieved an overall success rate of 38.9%.
Okay, 38.9%. So that's another jump, about 10% better than the API-only agent, and a whopping 24% absolute improvement over the browsing-only agent.
Exactly. And the paper highlighted this 38.9% as achieving state-of-the-art results for task-agnostic agents on Web Arena at that time.
Task-agnostic, meaning it wasn't specially trained just for GitLab or just for shopping. It could handle different kinds of tasks.
Correct. A general-purpose web agent.
What's really interesting there is how the hybrid agent worked. Did it mostly use APIs or mostly browse or?
It really mixed it up. The data showed it chose to interleave browsing actions and API calls in the vast majority of tasks, almost 78% of the time.
So it was constantly switching back and forth.
It seems so. And its accuracy was pretty consistent, whether it ended up using only APIs for a task, 38.5% success, or combined browsing and API actions, 38.2% success. That flexibility to choose the right tool for each step seems crucial.
And did performance vary by site? Like, did sites with better APIs see better results?
Absolutely. There was a clear correlation. Sites with good, comprehensive API support, like GitLab and the Map service, saw much higher success rates for both the API-based and hybrid agents,
Compared to?
compared to sites where the API support was weaker or they had to add custom ones, like the Reddit clone.
Which brings us back to that point about API quality and availability. It seems critical.
It really is. And that's a key takeaway for you working in security. The effectiveness of these agents is directly tied to the API landscape of the target application.
Let's revisit that Reddit example. You said the API agent initially did poorly.
Right. With the first set of 18 APIs they identified or added, the API-based agent only had a 9.4% success rate on Reddit tasks. Just couldn't do much.
But then they added more APIs.
They manually added 13 more, specifically targeting functions needed for the tasks, like post-voting. And after adding those APIs,
The success rate went up.
more than doubled, jumped to 18.9% for the API-based agent on those same Reddit tasks.
That's a direct link. Better API coverage equals better agent performance. If the function isn't exposed via an API, the API-only agent is just stuck.
Precisely. It underscores that the API is the interface for this type of agent.
There was also that interesting side note about site quality.
Yeah, the researchers observed that websites that had well-designed comprehensive APIs often also had cleaner, better structured GUIs.
Suggesting maybe better overall engineering practices?
Possibly. Or that thinking clearly about machine interaction helps clarify human interaction design too. And interestingly, that cleaner GUI could sometimes even help the browsing agent perform a bit better because the structure was easier for it to parse.
Okay, performance is one thing. What about efficiency? You mentioned API calls might replace multiple browsing steps. Did that play out?
It did, if you measure efficiency by the number of steps taken.
Okay.
The API-based agent was the most efficient by that metric, averaging just 7.8 steps per task. Make sense? One API call can grab data that might take many clicks and scrolls to find visually.
And the others?
The browsing agent averaged 8.4 steps, slightly more. The hybrid agent, maybe surprisingly, averaged the most steps at 8.5.
Huh. Why would the hybrid take more steps?
The paper suggests it might be the overhead of deciding which method to use at each point, or maybe sometimes combining methods requires extra steps to bridge between a GUI action and an API action.
Okay, so fewer steps for the API agent. But efficiency isn't just steps, it's also resources, cost. How did they compare there?
Ah, now that's where the story flips. When you look at computational cost, primarily the cost of running the LLM,
The browsing agent was cheapest?
by far, averaged only about $0.10 per task. Very low cost.
And the API using agents?
Much more expensive. The API-based agent averaged around $1.20 per task,
12 times more.
and the hybrid agent was the most expensive, around $1.40 per task.
Why such a big difference?
It comes down to the prompts. Remember that huge amount of API documentation, especially for sites like GitLab using the two-stage approach, feeding even those summaries and then the detailed docs on demand into the LLM's context window drastically increases the number of tokens processed.
Compared to the browsing agent, which just needs descriptions of basic actions like click or type.
Exactly.
Yeah.
Much smaller action space, much smaller prompts, much lower token count and cost.
So we have a really important trade-off. APIs give you better performance, higher success rates, often fewer steps.
But currently, they come with a significantly higher computational price tag because the LLMs need to process all that technical API documentation.
It's the cost of giving the agent that richer, more structured machine interface.
Interesting. Can we look at a specific example, maybe one where the API really shone?
Sure, the paper gives a great one. The GitLab commit count task.
Okay, what was the task?
Find out how many commits a specific user made to a specific repository and A11 Meet project.
How did the browsing agent do?
It failed. It tried to navigate to the commits page in the GitLab web interface, but then it faced having to scroll through potentially thousands of commits listed on the web page. It's slow, inefficient, and it hit the maximum step limit before it could count them all.
Makes sense. That's not how a human would efficiently do it either if the list was huge.
Right, but the API-based
It
agent...
succeeded quickly, easily. It generated a few lines of Python code using the request library. It hit the specific GitLab API endpoint for retrieving commits for that project, like Git etf4 projects, project repository commits, maybe with a parameter for the author.
Got back a nice structured list.
Exactly, a
Yeah.
JSON response. Then it just needed a simple loop or filter in Python to count the commits matching the user ID. Task done in maybe 2 or 3 efficient steps.
Clear win for the API there. What about an example where the API approach didn't work?
Okay, consider the shopping admin review deletion task. The goal was to go into the admin backend of the e-commerce site and delete all the negative reviews for a particular product. Sybil running short.
How did the API-based agent fare?
It failed completely.
Why?
Because for this specific task on the benchmark shopping admin site, there simply were no API endpoints available for listing reviews, let alone deleting them based on sentiment.
Ah, back to that API availability problem. If the API doesn't exist, the agent is powerless.
Exactly. The interface it needed wasn't there.
Did the browsing agent manage it? Clicking through the admin GUI.
No, it failed too. The paper described the task as too complex finding the product, navigating to its reviews, visually identifying negative ones. How do you even define that reliably for an agent? Selecting them, clicking delete. Too many steps, too much ambiguity in the GUI for the browsing agent.
So both failed. What about the hybrid?
The hybrid agent succeeded.
How? If there was no API for deletion.
This highlights its strength. Since there was no API for the core task, review deletion, it must have primarily relied on browsing actions. It likely navigated the GUI to find the product and its review section.
Okay.
Then, it probably used its ability to parse the visual layout to identify and click the delete buttons for the reviews it classified as negative. It fell back to the GUI interaction when the API wasn't an option, but perhaps used APIs for other parts of the setup or navigation if available. It used the best tool available, even if that tool was the less efficient GUI interaction for the crucial step.
That really shows the power of flexibility. Use APIs when you can, but fall back gracefully to simulating the human when you have to.
Precisely.
Okay, pulling this all together then, what are the big takeaways here for security folks listening?
Well, first, just recognizing that AI interaction with web apps is evolving. It's not just about simulating clicks anymore. Agents using APIs represent a different, potentially more powerful way to automate interactions.
And that means we need to think about the security implications differently, right? APIs become a primary interface, not just for developers, but for these advanced agents too.
Absolutely. This research underscores that APIs, being machine-centric, can provide a more direct, structured, and often efficient path for an agent, whether benign or malicious, to interact with application logic and data compared to navigating the often messy GUI.
So from a defensive perspective, robust API security becomes even more critical than ever, all the basics.
Authentication, fine-grained authorization, rate limiting, strict input validation, monitoring API usage patterns, all that needs to be rock solid. Because you might have agents hitting these endpoints at scale, programmatically.
It also makes you think about API design, doesn't it? When developers expose functionality via an API, are they considering how an agent might use or misuse it?
That's a great point. This work shows that the availability of specific APIs directly enables agent capabilities. If you expose an API to delete all users, you need to be extremely sure only the right entities can call it, because an agent could potentially automate that far more easily via API than by clicking through a complex admin GUI.
And looking ahead, the paper mentioned agents might get even smarter about APIs.
Yeah, they touched on future possibilities. Imagine agents that could automatically discover APIs just by interacting with a website, even if there's no documentation. Techniques like automated web API mining could potentially allow agents to build their own understanding of an application's API surface.
That would make them incredibly powerful, able to adapt to almost any site, but also opens up huge security challenges. How do you defend against an agent that can find and exploit undocumented or poorly secured APIs on the fly?
It means security needs to be built in, assuming machine interaction is possible and likely, across both the GUI and, critically, every single API endpoint. Your attack surface isn't just what users see, it's everything a machine can talk to.
A really important shift in perspective.
Definitely.
That's all for this bite of InfoSec Insight. Until next time, stay sharp, stay curious, and keep breaking things responsibly, of course.